Hello everybody, it is 12:59 p.m. Central Time on Monday, December 19th, 2016. Hope you guys are doing good. Welcome into the Earthquake 3D live stream where we daily recap events from around the planet, and we do issue semi-daily and weekly earthquake forecasts for new activity to watch for around the planet. So let's just get into things that struck since last night. If you would like to know the areas we named last night, you can go over to my YouTube channel and watch the second video in my playlist, and it's titled Nightly Update, New Warning Areas. You guys can check that out. We named several spots, and let's just get into it. So, first spot that's the most significant that I see is actually over here in South America at the Ecuador-Colombia border region. And this is significant. Last night in our update, we told everybody that pressure would transfer off this 6.4 and follow our small interior arrows up the mountain range and strike our halfway point at the Ecuador-Colombia border. Now, since last night, the Ecuador-Colombia border was struck, and we have fatality reports coming out of the area, guys. So there were fatalities associated with this earthquake in Ecuador at the Colombia border. Also, take a look at where the swarm is in relation to our arrow, and I talked about the tip of the arrow last night as well. Said that the tip of the arrow was pointing right to the spot where we needed to watch, and literally you can follow that straight line right into where the earthquake struck. It's a shame. It's terrible that people died. It's horrible that even one person, if one person died, it's because they didn't get the warning. I'm taking it very serious, guys, because when we issue a warning for the area of Ecuador at the Colombia border, and we tell people to watch out for a significant size earthquake or earthquakes or a swarm to strike, I really want them to get that warning. I do. Not because I'm going to go viral or anything, even if it just goes to a few thousand people in the location. That we want to try to get people warned so that they can either sleep by the door, sleep outside for a night. You know, they're in South America, so they could go sleep in a hammock, okay? I mean, it's warm out there, so just be aware that it was hit. Now, this is in conjunction with the other tip of the arrow being hit as well. Take a look at the other tip of the arrow. Then we have a moderately deep earthquake striking right over our letter D, which stands for deep earthquake. All in all, pressure is trying to seek its way right now around from Ecuador up through Colombia into Venezuela. So it's just amazing. I mean, take a look at it. Look where our arrows point. 2 clusters at each arrow tip and a fatality at the warned location in Ecuador. Secondly, coast of Honshu, Japan was struck by a 5.5. And this is a low ball, actually. If you guys go over and check the USGS feeds, or if you check the EMSC, you're going to see multiple earthquakes recorded above 5.5, and this is their typical downgrade low ball. I would like to point out as well that it does seem that there is some kind of half magnitude downgrade that's been happening lately almost on every single earthquake that's going on. So look at our magnitude list here on the right hand side. You can see 5.2 and 5.5 right at the top of the list, but then we start going up. 6, 5.6, 5.5, 5.5, few low 5s, 5.9, 6.3, 6, 6.3, 6.3, 6.2, several upper 5s, going back into the upper 5s, then going back up into 6s. Okay, so enough stations detecting 6s that I would dare say this is either an upper 5 or a lower 6. We keep going down the list. I mean, it's not just 1 or 2 stations that's detecting above 6.0. But these low balls, they need to throw out the ultra low balls and the extreme high ones and go with the average in between. Look at the number of stations reporting in on this and look at the number of 6s being reported in. I mean, there's enough that I'm wondering, okay? So, 5.5, 6.0. What were we looking for, guys? What were we looking for? We were looking for a 6.0 to strike here on the coast of Honshu by today. Now it's hit. The exact spot. So, two exact spots, Japan and Ecuador. And I think at this point, since we had a 5.5 and swarm in Ecuador and a 5.5 and swarm in Japan, that we can definitely connect Ecuador and Japan. And we're going to need to put a yellow arrow, and I'm going to add a yellow arrow in on this, the first one. It's not going to be the last. This will probably be the last addition. These yellow arrows that I'm going to start adding to this will be our last addition to the pressure transfer map. The yellow arrows will signify, and maybe I'll make them a dotted arrow, it will signify the bouncing back and forth location, where we'll see Japan get hit and Ecuador get hit with similar sized earthquakes. Same with New Zealand and the coast of Chile, usually in conjunction with deeper earthquakes. And look what we have at both locations, deeper earthquakes. Look what we have in New Zealand, 4.5. Look what we have down here in South America, 4.8. Similar sized earthquakes, both sides within just a few hours of each other. So I would dare say they are connected. And we're going to have to add a yellow dotted arrow to show that they're connected and put a little word on there that says connected. Okay, so they are connected. I said last night, if Japan was struck today by a similar sized earthquake as what hit in Ecuador, one of my viewers even raised the question. They said, is Japan connected? You were talking about it being hit before when Ecuador is hit, and it's been hit multiple times back and forth. Well, now here's another example. Hit back and forth. Also, look at the connecting point. If you were to go as the curvature of the Earth goes and connect these 2 points, look what's right across that area. We have Hawaii, and we have that hidden volcano that put off the 6.0 that the USGS hid a couple weeks ago. Okay? Now, over towards Europe and the Middle East, we see that North Pakistan, North Afghanistan, West China was hit by a series of 4s again. That's now pushing into Europe again, right across Iran, being struck again at the same location. But the main difference today is Caspian Sea, Black Sea, all of Turkey, and pretty much all of Greece swarming out with 3.0 activity, not just 2s. So we've gone up a whole notch. So what does that mean for Italy? Italy, it means 4.5 potential. 4.5 potential. Why 4.5? You have a 4.7 plus about 4 or 5 different 3s. So that might equal a 4.8. But the 4.8 will lose a few points, and when it hits Italy, it should be more like a 4.5 to 4.6. So keep watch. Very soon. Should strike very, very soon. Also, I did notice something, and I'm going to have to go back and pull my videos just to prove this to you guys. I was looking at the USGS site. Excuse me. Still suffering from this. I was looking at the USGS site, and I noticed that there's been a few slight changes that they've all of a sudden made to their plate boundary list, guys. Yes, they changed the plate boundary. Now, I don't know why they would change the plate boundary. I don't know why they would update the plate boundary to be something different than what it was before. It's not like the plate boundary has moved at all. The plate boundary hasn't moved at all. But the USGS has moved the red line in Iran in particular, going through central Iran. It used to come down and go around the bend, come down here, okay? And I'm going to go pull my old videos to prove that. Also, that they've disjointed and unconnected the lines of the plate boundary by 1,000 miles. They have moved the plate boundary lines, guys, on some of these. And to me, that is absolutely asinine. Okay, plate boundaries aren't going to change. They aren't going to move. I would understand if they needed to add additional ones that they may have found. But to change or edit or somehow switch the plate boundaries, you know, change the red line map all of a sudden. What? Changing the red line map all of a sudden. This is a question, I mean, look, you got to ask this question. If they're going to change the red line plate boundary map, why would they change the red line plate boundary map? Do you believe the plate boundaries changed, or do you believe they changed? the USGS. I would believe that instead of having the plate boundaries magically all of a sudden move, which they couldn't, they could not move, they could not change their locations, that the USGS has now changed their plate boundary map because someone told them, or they got word, or they knew that we were using it, and we put our red arrows along the lines, and then they changed the red lines, like as if the plate boundary is going to shift. That, to me, is extremely troubling. Okay, so that's what's going on. We've got a situation developing out from our pressure transferring. Europe, you're under the gun with a mid-range 4. West Coast United States, you're looking for a 6.0 in Northwest California near Eureka, most likely very close to land, actually. Hope I'm wrong, hope it strikes more out to sea, but should be hit. Oklahoma swarmed out again with just a few microquakes, but still, Oklahoma being hit today. Let's turn on our smaller earthquakes really quick. Our swarms still happening here in California and Nevada, and Southern California now swarming out. Take a look at it, clustered around Salton Sea and our silent zone in Santa Barbara. Now I'm looking for a near 3.0, 3 point something to be striking in Santa Barbara, the largest of the bunch so far today. One other thing that's showing up here, guys. Whoa, 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 hold on. Everybody, put on the brakes, put on the brakes. We've got a deep earthquake below Mammoth Mountain. We have a deep earthquake below Mammoth Mountain. This is rare. We don't normally get deep earthquakes in California. The last time we had a deep earthquake in California, it was followed by shallower, larger movement, 2 magnitudes larger. And it was a 2.0, and it was followed by a 4.0. So here we are again. This one is deep. You can see it right here. Hold on. You can see it raised high off the globe. The only luck on this is that it's a smaller earthquake. It's only in the... let's see. Is this a 2 or a 1? Or a 0? It's a 2.1? No, that can't be it. That can't be the right one. Okay, which one is it? Is it a 0 or is it a 1? It looks like it's a 0. Nope, it's a 1.2, which means there's a potential of a shallower 2.2 to 3.2. Now I'm going to get the coordinates on this and we're going to go look it up, just so people can see what's there. I've shown this many other times, but this is a new development. This is the first deep earthquake that I've seen shown down below Mammoth Lakes or any of Eastern California at all. This is extremely rare, beyond rare. It's been reviewed by a seismologist, depth 160 kilometers. This is proof that the magma chamber down below Mammoth Mountain has been compressed. This is what it's proof of, guys. I knew it. I knew it. The magma chamber down below is being compressed. There is trapped pressure between California and Oklahoma. It hasn't released there, guys. It hasn't released in Oklahoma, which means the pressure hasn't gone anywhere. It is staying pent up in the plate between California and Oklahoma. And then you zoom in on the area, look where our earthquake struck, deep earthquake. Right at a tip of Long Valley Caldera. Oh, man. Okay. Well, guys, with a deep earthquake at this location, and the magma chamber being compressed, and the fact that it's on the flanks of Mammoth Mountain, Lookout Mountain, next to a series of old craters, and I mean, some of these are so old, they're covered in trees, and, you know, it doesn't even really look, it's an obsidian butte there, by the way. That right there is an obsidian butte. We have more to the west, in case you guys are wondering. This one's called, here, Obsidian Dome. Let's see. Here we go. We got a place mark on there. Obsidian Dome. And these are well-known volcanoes in California. People ski on Mammoth Mountain, but it's part of a greater volcanic complex called the Long Valley Complex, or Long Valley Caldera. And we have Division Creek Volcanic Butte, Taboos Creek Volcanic Cones, Over to the east, Charlie's Butte volcano. This one's really impressive looking, actually. Charlie's Butte. I don't know if anybody here's name's Charles or Charlie, but you've got a butte somewhere. So many of these Crater Mountain. Look at the lava flows on here. Look at the lava flows on Crater Mountain. So that was a thick, viscous lava flow. It wasn't too liquidy. When it came out, it rolled down the hill and went maybe a mile or two to the east and stopped. But it was a huge eruption when it happened. Same with Red Mountain Volcano, Charlie's Butte, Taboos Creek, Division Creek, and going further down to the south. It doesn't stop there. The volcanoes keep going down Long Valley. You can see them down into the Coso Volcanic Field, down to Volcano Peak, with the lava flows there. So, deep earthquake happening down below Mammoth Mountain. Compression happening on the magma chamber itself. Usually when there's a deep earthquake below a volcano, it's a sign of a coming eruption. My God. I see in the comments field somebody talking about, yeah, Mammoth also is part of Mono Lake supervolcano. Let me show that to you. Even though it's happening by Mammoth, about 100 miles to the north, or less actually, is Mono Lake supervolcano. And we can go ahead and pause this. Mono Lake Volcanic Field is what the Smithsonian calls it. But this is a past blast caldera, this basin. And out of the center is a new dome rising, and it's been rising for a few hundred years. When this blew in the past, this is half the size of Yellowstone. So we would call it a half of a supervolcano, right? But it's on the tip of the Long Valley, which makes sense that, you know, there's going to be deflation. Take a look at these volcanoes here, where Mammoth Mountain is, right? Look how far away they are from the supervolcano here. Now we're going to go use Yellowstone as another example to show you how this is common. Okay, here's Lake Yellowstone in Yellowstone. Now look over to the west, what we've got. I went camping down here, about the same distance, about 100 to 150 miles away. Hell's Half-Acre Volcano, and these are lava flows. Here in Idaho, go on for miles. Went camping here when I did the radiation road trip after Fukushima blew back in 2011. Several months after Fukushima blew, I bought Geiger counters and drove across the country taking radiation readings. I stopped here on my way to the West Coast, went up to Washington State, and waited for the rain to blow into the Olympic National Forest, and took radiation readings on the mist, on the rain, in the deciduous rainforest, on the ocean shores, a few months after Fukushima blew sky high and blew all that radioactive debris supposedly over the United States. And guess what we found, by the way? Guess what we found? Nothing came to the United States, radiation-wise. I hate to break it to you guys, but the whole story on Fukushima, I know this is going to sound crazy, but I'm telling you, no radiation reached the shores of the United States. Low readings. Now, people had creative excuses for why that was. As it turns out, what I think happened over in Japan was that they took, after the tsunami happened, the power company there, which Fukushima was already shut down. You guys, most people didn't know this. They were already shut down completely. And the rods were already removed from the cooling tanks. It was in full shutdown. So how did the rods magically get back in within a day of the earthquake? What they did, they had 60 years worth of stored radioactive material. There was a big earthquake and a tsunami. After the tsunami hit, they immediately started taking the debris and putting it into what's called a casket. All the concrete and steel and all that stuff. And I believe they took the 60 years worth of stored radioactive fuel, buried it in a casket of tsunami debris, covered it with concrete, bury it, long gone, either out to sea or right on land. Then go around, sprinkle a little bit of radium or something that will produce a radioactive return around the reactors themselves, and collect billions of dollars while throwing away irresponsibly radioactive material stored for 60 years. If it blew sky high, the whole planet would be dead. And my Geiger counters would have been going hot this whole time. And it's not that there's anything wrong with my Geiger counters. Everybody's Geiger counter is showing the same thing unless they do a windshield wipe test, which is pulling ceramic brake pad dust onto their Geiger counters. So, in other words, they may have dumped it in the ocean, they may have dumped it into a casket, but it didn't blow sky high. They then blew the buildings the next day and collect the money for it. And that's why we didn't get radiation, still don't have radiation of any noteworthy size coming down anywhere at any time, even around the actual reactors themselves. They've gone back to normal life. And I saw somebody saying, is it, Kobe beef radioactive? No, because they buried the radiation. It didn't blow sky high. That's how Obama was able to stand up there and say, no radiation is going to reach the shores of the United States. How would he know that? He said it before the cloud hit. Well, what cloud? There was no cloud, as it turns out. So, that all being said, guys, volcanoes form next to the supervolcanoes. And down in California, it's the same way. Up here in Wyoming at Yellowstone, it's the same way. Over in the West Pacific, over at Toba supervolcano, it's the same way. There's Mount Cinnabung on about 100 miles away from Toba. So these supervolcanoes have large volcanic complexes that form next to them because of the amount of deformation that happens. All in all, this is a noteworthy amount of movement to happen since my update last night. And the spots to be hit, the fact that somebody was killed, even killed or injured or whatever down here in Ecuador, that to me is super troubling. Because there was a multiple hour warning for Ecuador. And now Ecuador been hit right at the spot where we warned. I almost think people need to hear it for themselves. They almost need to hear it on my YouTube channel. I can go dig it up. I can. I want you guys to hear the warning that was issued last night. Here it is. Potential for new large earthquake. Deep Pacific unrest taking place. And I don't know if this is going to be right at the point in the video where I issue the warning at 53 minutes. Let me rewind it by a few seconds. Let me take it back to like 52 minutes something, see what I'm saying. Be on watch over the next, let's put a 48 to 72 hour watch on this for the next 2 to 3 days. Being at Puerto Rico with a series of 3s and 2s. Oh, wait, I got to rewind it just a minute here. So it's more like 52 minutes.
Under serious pressure. The halfway point between these deep earthquakes, or this deep earthquake, and up here to the northeast at the bend of the Caribbean, the halfway point puts us into South Colombia, North Ecuador. So if there is the possibility for a large earthquake, most likely it's going to strike our fulcrum point between the two spots that are moving. And again, we're moving all the way up here in the Eastern Caribbean at Puerto Rico with a series of 3s and 2s, mid-range 3s. So trace the halfway point back down the red arrows down to our deep earthquake where the 6.4 is. And our halfway point comes in right here. So if you're in Colombia, if you're in Ecuador, if you're in South Central America, please be on watch over the next, let's put a 48 to 72 hour watch on this for the next 2 to 3 days. All right, there you go. You heard it firsthand there. You don't have to take my word for it. That's what I put out last night, telling everybody to watch out for. And Ecuador-Colombia border was hit today, now with a fatality reported, which could have been averted if they would have gotten the warning. Same with over in Japan. The only lucky here is that it struck on the coast of Honshu. We were looking from North Tokyo to the coast of Honshu. Pretty small little stretch in here, going from the bay up to coast of Honshu for a near 6 and a 5.9 hit. Now they downgraded it to 5.5, but many stations showing above 6. I'm willing to throw out the ultra high readings at 6.5 and stuff, and throw out all the lower, and our average in between there then takes this to like 5.8, 5.9. Right in the magnitude we warned for, in the exact spot we were watching. And how many days has it been since a 5 is hit? Or 6? A week? At least? At least a week, because here's the last 7 days, and the biggest earthquakes they have reported are in a 4. So we're a whole magnitude and a half, maybe even 2 magnitudes, higher than the previous earthquakes that were striking in the exact spot where we warned. I'm not bragging. Just got a personal message in there, you guys. Okay, whatever. You can send me messages private. I am not bragging. It doesn't sound like I'm bragging. I am telling you, scientifically speaking, the areas that we named were hit.
And nobody else is going to tell you that. There is no news broadcast that's going to come out and be like, guy on YouTube names Japan and Ecuador, and Japan and Ecuador are hit. They're not going to do that. I wish they would. I mean, they always make a big deal about it when somebody gets an earthquake forecast wrong, but here we are, and two of the spots we named with the exact magnitudes were hit again within the day of putting out the warning, and, it's crickets. Crickets. The reason there's crickets is because, well, we're basically refuting, or at least debunking, a good portion of your modern-day geology textbook. We're turning it all on its head, ripping out whole sections at a time as we discover new things, and that is not working out well for the professionals. They need to have something predictable that they can teach on a regular basis that's not going to change. That's what they're looking for. And unfortunately, science and things that don't change don't go hand in hand. They're not synonymous with one another, okay? I mean, they do not go together. Science is constantly changing. Dogmas in science, rules in science, laws in science may not change, or if they do, they're modified. We're not talking about any new laws or anything like that. We're talking about some new discoveries that already follow current laws of motion and physics. So the only thing we're adjusting here is outdated geology dogmas, rules that were set by people who really shouldn't have set rules. You know what I mean? Kind of like, this is how dogmas go, with rules set by people that are arbitrary in their own, understanding or decision making. So you can see, oh, by the way, both arrows pointing right up to our spot. Look, it's a recombination point here along the coast of Japan. I think it's pretty obvious now. The only spot left to be hit is going to be over here between Taiwan and Philippines at our other middle fulcrum point. It should be struck by a near 6, maybe a 5.9. I mean, if it goes as low as 5, it'll probably be a 5.9, then they'll downgrade it to a 5.5, right? Okay. Yeah, I'm being sarcastic there, but the downgrades are getting annoying. They're doing them by a half magnitude. In Oklahoma, swarmy. Look at this. New swarm in Oklahoma over the past couple days. And nobody should be shocked by this. The swarm in Oklahoma is expected, but it's smaller. And the pressure is trapped in between the area where the swarm in Oklahoma is at the fracking ops. Fracking in oil at these locations. You know what? We should go look one of them up. For new viewers, you need to see it. This is always impressive. And not impressive in a good way. This is mind-blowing. Let's call it that. This will blow your mind that they're doing this. And then you're going to understand why earthquakes are striking here when I show it to you. Okay, now all these yellow place marks are spots where I've marked previous frac wells, okay? So this is, as we get into the area, we have a frac well right next to here. We have a couple. Let me zoom in and show you. It looks like they removed this one. Wow, okay, they removed that one. The imagery date here is 2016, so they removed that frac well but left the one right next to the road. Maybe we might even have a street level on this. Let's see, hold on. Okay, let's go. Do we have street level? Sure do. Let's see if we've got... isn't that beautiful? Nothing says beautiful Oklahoma like an oil well and an injection operation. Beautiful. Oh, and a pump house. Maybe I should zoom in on that. If you guys are looking full screen, you should be able to see this. Okay, so nearby well there. There's thousands of these, so when I said you're going to be blown away, you're probably not blown away by one well. Let me back it out, show you how big the operations are. Okay, so we zoom in on the areas, and what you're going to see here, actually, this is kind of interesting too. Next to the subdivisions, and I mean right across from the houses in the road, and I mean sometimes even in their backyards. And this is no exaggeration. In between their backyards, you got people living here, and then right here is the frac well. Let me get a sip of my coffee. All right. So, these are all over the place. Thousands of them. And I got tired of marking them. So, for every one that I have marked, I would say there's probably 500 to 1,000 that are not marked. And that is no exaggeration. So for every one I've got marked, there's thousands that are not marked. They're all over the place. They're extracting gas and oil from these locations. So we get back over to the earthquake epicenter. Let's quickly search the coordinates again. There we go. Right next to the old frac well. What do we have right here? Got another one right here. Got another one right there. Okay, and what's that? What is this? A heliport of some kind? What is this place? That's really interesting. Some kind of airport, maybe? Helicopter pad? It's a large paved area of some kind for no good reason. So it's a past spot where we've had other larger earthquakes. Look at that, 4.3, December 29, 2015. So a year ago, it was struck by a noteworthy size earthquake, a 4, in the winter. Here, look, a 4.2, January 1st, 2016. So a couple days later, first the 4.3, then a 4.2, 1 year ago. Wow, wow, wow. Okay, well, it could happen again. Not could. It will happen again. It's just going to depend on how long is it going to take for this pressure to come out of California and Nevada and go over to Oklahoma. I mean, it's kind of been bouncing there, hitting it back and forth, tapping it. It hasn't fully hit it yet. It's just been tapping it from the side. Now we got the deep earthquake at Mammoth Mountain. Boy, wouldn't that be wild if a new eruption happened at Mammoth Mountain? But I'm not thinking that's going to happen. 1 to 2 magnitudes larger than our deep earthquake, which puts us at like a mid-range 3. Not that big of a deal earthquake-wise. But to see deep earthquakes down below Mammoth Mountain in Eastern California, very rare, sign of activity, sign of pressure. And in case you guys didn't see, maybe you didn't see, you know what, let me get a display capture on here for you. You probably didn't see the frac wells. My God, man. This has been happening way too often. Way too often. The switchover isn't working when I'm doing the update, and that the people can't see what I'm pointing to. Okay, let me show you one more time. Here's Oklahoma. Okay, take a look at this. Here's Oklahoma, and our earthquake struck. Let's zoom in. Okay, here's our earthquake epicenter right here. And we've got an electrical substation. We've got an old frac well that used to be right here that I had marked. They have since removed the well, but right across the way, right next to the school, or whatever that is, we got a frac well right there. And then we've got a huge operation that goes on for miles. Okay, every one of these into the residential areas, into the houses even. Look at this. Look at this one, guys. See these nice houses here? I would consider these nice houses. Look, they've got pools. They look like semi-McMansions there. Let's take a street level and just show you the nice houses before we go look at the frac well. I don't know who lives here, but looks nice to me. That looks real nice. Man, I bet they paid a lot of money for your house. Too bad it's right next to a giant fracking operation right behind your backyard. This can cause earthquakes. It can cause cracks in your foundation, surface deformation. Oh, wait, look at the road here. Look at the road here. Yeah, surface deformation. All right, there's a frac well right there, and I would dare say there's some deformation happening on your roads here because your roads are more cracked than not. Look at that. You know, with all that oil and gas, you think they could crank out some asphalt for you for some new roads if they're going to be cracking them up that way. Look at that. Boy, wouldn't you say? That's not just an old road, guys. Look where the cracking really starts. Look at this. Now, the cracking goes on, but look where they're... This is Imagery Days 2016, guys. 2016. Wow, man. Wow. Okay. So, nice mansions, and then right behind it, we've got frac wells. And they go on for... I mean, this is a kind of a lower example, but we can just keep going over to the west. See, like I said, for every one that I marked, There's 1,000 that are not. This is an oil well. This is the gas well. Everywhere where you look and you see one of these pads, it's pretty interesting because, or not interesting, it's not good news for the people who live there, but look at this. Nestled in here, right next to your awesome house. Do we have a street level? Sure do. Let's get a look at the house. Nice, look at that awesome house. And then we get right up over the way, and we've got our frack well up at the top of the hill. There it is. There it is. Nothing says suburbs, nothing says countryside like oil and gas. Wonderful. There it is, guys. So, that pretty much sums up my video for now. I'm sorry you didn't see the tail end on that. But there is one other thing I would like to show you while I've got you here on screen. Since we're going to be going to look at things, I think it would be prudent for you to observe this. Take a look at this. This is a video I put out 12 hours ago. It's kind of going semi-viral. It's got 23,000 views already. And I'm going to mute my voice. And what you're going to see here is something that is pretty interesting. I don't know what it is. I don't know the source of it. We don't know the cause. We've got everything from people saying it's the rapture, to people saying it's gamma rays, to people saying it's solar flares, to people saying it's coronal holes, people trying to say all kinds, spiritual. I don't have an answer for you as to what the source of this is. All I can tell you is that there is a global energy wave hitting us right now, and there is no doubt about it. This is ongoing. So this is the video I made last night, 12 hours ago. I'm going to take you to the most recent view of this so you can see the real-time screenshot of what's going down right now. Let me get this off the screen. This is the MIMIC TPW, the MIMIC, which is microwave background imagery. This is the most recent frame. We'll let this play through, and where it stops is right now, 3 hours ago. So where it stops right there, 12:19 at 1700 hours UTC. So 1700 hours UTC, it is now 1936 UTC. So this is 2.5 hours old, and it will update very soon, every 3 hours. So, large energy wave of some kind, and it's currently impacting the northwest portion of Canada. The wave is going up north of BC, right along the North Island of BC, and then out to the west-southwest, down across New Zealand. Right now, right there, east of New Zealand. Ironically, east of New Zealand, up to Alaska, is the magnetic conjugate point for HARP. But you see how it bends down and goes around the South Pole? You have to imagine that plotted on a globe. Okay? That if this was plotted on a globe, you would see this stretched out around the entire planet. As opposed to an S-shaped wave, it would go all the way around and come on the other side. So it would go from the west coast of the United States, around, bend down around India or South Africa, and then come back up over to the east and meet back up with this over America. So it would be meeting kind of over, actually it would be meeting over northern Canada right now. It's happening right now as we're talking. That's a wave of some kind, guys. It's not a glitch. It's not an error. The only other thing I think it could be would be a practical joke done by the people at the university. Maybe they watched somebody's videos online, you know, recently with the galactic wave stuff, and they decided it'd be a funny joke to go put it on the, you know, do this. But other than that, oh, you see these white portions that start forming after the wave comes through? This is missing data due to the excessive amount of detection that's going on here. So it causes an error on the feed after it happens, and we see this happen time after time after time. But we've never seen anything like this before. Never. I've never seen anything like this before. No one I know has seen anything like this before. And we got somebody down below my video trying to, you know, play a YouTube expert on radar and telling me that it's impossible to generate these things. You know, again, they don't know what they're talking about. For anybody to say it's impossible or to declare what they know what it is, it's foolishness. They couldn't know what it is because it's never happened before. We've never seen anything like this before, so there's no way anybody could know what it is. And anybody who declares they do know what it is pulling something out of their you-know-what to say it. In other words, they're just supposing they know what it is. Nobody can know what it is. We have to watch and wait and see if there's any effect. Okay? And the effect, when there's this large of a microwave detection going on, but there's not a source for it, we have to look to places out beyond planet Earth. So some kind of solar event, some kind of extraplanetary event, some kind of extra solar system event that could be impacting Earth and causing this. Don't discount it. As a scientist, you can't discount it. You have to look and observe and wait and see and test it. So, if we get the biggest earthquake ever, or if we get a huge amount of eruptions or something weird like that, then you'll know. You'll say, the galactic wave just hit. Okay, I was not a believer in this galactic wave stuff. I was going off verbally on BP Earthwatch. Now I'm standing corrected. I had to issue an apology. I had to actually say I got it wrong. That something is hitting the planet right now. The chances of it being a coincidence, while I'm not going to completely discount coincidence, the chance of it being a coincidence like this, where a wave is hitting the planet at the same time you've got a bunch of videos on YouTube that are claiming a wave's going to hit the planet, like I said, either somebody at the university saw one of those videos and is playing a practical joke on the world right now. That is a possibility. A remote one. Very remote. But it still is one. It's still a possibility. Some jerk at the university said, ha 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 ha, and they went and did it. But the other option is that it's real. And if it's real, which is, as a scientist, if you can't discount the fact that it could be real, then you have to at least be open to the fact that it could be a huge amount of energy impacting Earth right now, being reflected off the atmospheres like the ionosphere, magnetosphere, and actual physical atmosphere, reflected off back towards the satellite observing, and then that causes a wave to show up. And if it's reflecting back and hitting Earth, then there's something in between the satellite and Earth that's causing this, which would be the wave. Okay? Oh boy, and Super Darn Radar and the others talking out, giving us these things, showing it up as well. So I would dare say, if Super Darn is involved, and we've got the Mimic showing it, and it's happened before when there's been X-class flares or CMEs directed towards Earth, please don't discount it, guys. Please, I'm asking you to keep an open mind and keep watch. Don't discount it. It's going on right now. The link is down below my video if you guys want to check it out. Again, my video is over on my YouTube channel, so feel free to go look that up. It's pretty interesting. Yeah, so there you go. One last time, Japan was hit as expected on the coast of Honshu. Ecuador at the Colombia border was hit as expected with a fatality report or reports. The two arrows were hit, are two large arrows pointing across the Pacific at the tips of both arrows. And back over here to the west, we're looking for new activity to develop out further to the west, heading over towards Europe. Italy, you're in the mix for a 4.5 within the next day or less, most likely by tonight. And that's, and a deep earthquake below Mammoth Mountain, indicating that the pressure is indeed trapped between California and Oklahoma, tapping Oklahoma, but not fully releasing in Oklahoma. So it's just slightly tapping on the side of Oklahoma, causing these small earthquakes. But the potential for a large one is there as long as this keeps going on. Okay? And when I say large one, it could either lead to a volcanic eruption at Mammoth Mountain, which I don't think is going to happen, or more likely a larger release finally once this all's said and done. How much longer? Maybe a day or two? I don't foresee it going much longer until a new earthquake comes in on the west coast, should be in the 6.0 range. Vancouver, BC, look, this is day number 3 of the 4-day watch for the 5.9 to 6.0 to strike near Vancouver. Now you've got this giant galactic wave coming over you right now. I don't know what to make of that, other than it's happening over the last 3 hours ago, I should say. So right at about 8 a.m. your time, that wave is over you. Now 3 hours later, it's probably moved, but You know, it was right over you. So we're watching two spots on the west coast, northwest portion of California, Vancouver, BC, 5.9 in Vancouver, BC, 6.0 on the coast of California. And that's all I've got for you. Okay? Much love to everybody. Looks like somebody's dropping a link into spaceweatherlive.com. The coronal hole. Yeah, it can't be a coronal hole. This I can tell you. It cannot be a coronal hole. The coronal holes don't ever really show up. We're talking about a large amount of charged particles, not a strong solar wind. So that's something that, again, I'm familiar with this to some extent because I've used the mimic so many times in the past to, I've used the mimic so many times in the past, and it shows when there's solar events, but not coronal holes. As a matter of fact, coronal holes are the only thing that don't show. Just a strong solar wind doesn't really show. We're talking about large amounts of charged particles emitted from a solar flare or a CME or a filament burst heading towards the sun, or heading from the sun towards the Earth. So if it's Earth directed, if it's a large CME, if it's a large solar flare, that's when there's a large amount of charged particles that come in and excite and cause a reflection on the mimic. The mimic is, again, in microwave, so we're getting a microwave reflection. Okay, so that's what I've got for you. Anything else goes down, I will be back in. Peace out.